All right, let's talk about some more topics from Chapter 1. The law of multiple proportions and Dalton's atomic theory would come next. John Dalton lived in the into the 1800s, and his concepts have held for decades and centuries. The things that John Dalton proposed in those days have been found to be largely very correct. The law of multiple proportions is one that's a little different from the one about definite proportions that we had in the previous discussion. It tells us that elements can combine in different ways to form different chemical compounds. So depending upon which compound it is, there's going to be different mass ratios that are simple whole number multiples of each other. So nitric oxide and nitrous oxides, whose formulas are not shown here, are two different examples of combinations of nitrogen and oxygen. In these examples, we have different proportions. So 7 grams of nitrogen combines with 8 grams of oxygen in nitric oxide. In its cousin compound, it's 7 grams of nitrogen with 16 grams of oxygen. How does that work? Well, nitric oxide is NO, and it has only 1 oxygen with each nitrogen. And NO2, nitrogen dioxide, contains twice as many atoms of oxygen per nitrogen as nitric oxide. So they're combining in different ways so that the mass ratios are simple whole number multiples of each other. They're going to combine in 2 different ways, and they're always simple whole number multiples of each other. The rest of this discussion requires a little bit of discussion about Dalton's atomic theory. The things that Dalton came up with in the 1800 time frame that are still largely truly held today, in spite of his limited information. Elements are made up of tiny, tiny particles called atoms. An atom means you cannot split it. It cannot be split and still be an atom, and or still be the same substance. Cannot be divided to anything smaller, and that's what elements are composed of. Is the tiniest particle is called an atom. Cannot be divided further, that's the atom. If you split it further, it's no longer the element, and it has different characteristics. Secondly, Dalton's theory tells us that each element is characterized by the mass of its atoms. The masses are characteristic and important, and the atoms of the same element have the same mass, but atoms of a different element have different masses. So that's part of what Mendeleev used when he was trying to figure out the periodic table. Different substances had different characteristic masses, and that's what gradually led us to our periodic table today. So each element is characterized by masses and a specific mass. The third component then of Dalton's theory is the chemical combination of elements to make different chemical compounds occur when atoms combine in small but whole number ratios. So you don't ever have a fraction of an atom combining. They have to be in small whole number ratios when chemical combinations are occurred. That's what chemical reactions are. Chemical combinations are always going to be in whole number ratios. And the last principle, the last concept, if you will, is that chemical reactions only rearrange how atoms are combined. In chemical compounds, the atoms themselves don't change. In other words, this is the conservation of matter. Nothing is created or destroyed in chemical reactions. So we only rearrange them when chemistry is taking place. These were postulates that Dalton put forward in his theory, which we hold to today. I will stop this recording and move on to a new topic.